Alright everyone, I haven't made a YouTube video in a little bit, but I just wanted to make a real quick one showing how to create prototypes in Blender by measuring things using micrometers, and just do a little bit of a walkthrough. And today I just wanted to make a camera like this. It's just a USB camera. It can be bought off Amazon. I think the brand's ELP. But anyway, we're going to be using Blender as the prototyping software, and you can use your 3D modeling software of choice. It's basically the same concept all around. So go up into your desktop and double click the Blender to bring up the Blender software there. And we're just going to start off with the blank project, which is pretty much standard, just the cube with the camera. And I'm just going to delete that cube. Actually, you know what? I'm going to keep the cube in there, because what we're creating today, which is just going to be this little camera right here, I'm actually going to use the cube, and I'm going to create the base of the PCB, which is a printed circuit board. It's just this blue part right here, basically. So to start off, you'll actually notice that when you go and press 7 on your numpad, you're going to actually see that the cube is 2 Blender units long to start with, and that's sort of something that bugs me personally. If you hit 5, you can change into an orthographic view, so that's going to be 5 on your numpad, and that's going to make all the lines completely parallel, which basically just means that you can zoom in all the way or be as close as you want with your 3D virtual camera as you're panning around this thing, and it won't distort the image for a perspective view. It's more of like a mechanical drawing type view where everything's flat. So I'm just going to go back and hit 7 again, and what we want to do is, since this is 2 Blender units, we actually want to scale it down to 1 Blender unit. So I'm actually going to hit tab. That way all of the scales and rotations, and every time that I grab something using G in Blender, when I hit tab, it's going to actually take this square, which I had selected, this cube, and it's going to bring it into edit mode, which basically means that all of the transformations that I do to it are going to be permanent and won't have to be applied later. And that's actually something that's very important that you want to keep in mind, is when you're transforming these objects outside of edit mode, it's not as permanent. You still have to hit Control A in order to apply the location, rotation, and transform. You probably won't notice it in Blender though. You'll notice it more when you like import it as a collada or something into like 3JS. But anyway, this is just going to be about prototyping. So what we're going to actually do is, I have the camera, which we've seen, and I also have a pair of micrometers here, and these are really cheap. You can just get them at Home Depot. Mine were like, I can't remember, like 12 bucks. And it's a digital pair of micrometers, which means that to actually start it up, I'm going to have to hit this on button. And you can actually see the numbers pop up there. And to start off, I'm actually going to unscrew this just so that it's not as tight, and then I can roll with my thumb and get an accurate reading right here. So I'm going to start by measuring the thickness of the board real quick, and I'm just going to get that measurement so that you can sort of see what I'm doing here. So I'm just going to fit in the jaws of the micrometer into a flat area of the PCB. I'm just going to tighten them until you can see that we're at, what, 1.59. So now we need to get this cube into a single unit so that we can start scaling it. So like I said, it's actually 2 Blender units lengthwise, height, widthwise. So we're just going to hit S on the keyboard while we're in edit mode and do period 5 for half scale. And this is going to bring it into 1 Blender unit territory. So we can actually work with this and multiply it by the measurements we find. So we're basically making this a 1 Blender unit equals 1 millimeter scale. So what I'm actually going to do is I'm going to grab this by pressing G, and I'm going to hit Y, and then 1 on the number pad. Oh, I'm sorry, actually it's 0.5, so GY 0.5, GX 0.5, and GZ 0.5. And what you're going to notice is that's going to bring this cube here to have its lowest corner over right on the object origin, which is this little orange dot right here. Don't get it confused with these vertices though. This orange dot is the object origin, which means that when you actually relocate this object to another object using like Shift S or something like that, or some other shortcut that does a relocation, it's actually going to use that object origin as the snapping point. So you always want to pay attention to where that object origin is. So with this in the lower right hand corner, we actually have to select the datum on the actual object which we are going to be modeling, and it's kind of hard to tell what's which side's which on this camera, sort of. So I'm actually going to see this text right here, and you know what, I think that I'm just going to make the object origin probably this upper right hand corner. We just have to choose a datum. It doesn't have to necessarily be like an extremely complicated process. Just make sure to choose a datum on your object that you're modeling. So I'm choosing this upper right corner based on this text. And we found that this was a thickness of 1.59, so we can scale this in Z, and I'm going to make Z the thickness, 1.59. And here you're actually going to notice something. It's actually scaling into the negative. So if I go press 1 on the numpad, and then do S 1.59, or scale Z 1.59 really, what you're going to see is that below the 0 point on this in the 3D world, below the 0 point, it's actually scaling below that, and that's going to be annoying because then we're going to have to press G and grab it and then move it up on Z so that we have these lines one for one. So what we're actually going to do is we're going to change what the modification origin is. So we're going to do pivot center for rotation scaling, which is this button down here, and I'm actually going to make it the 3D cursor, which the 3D cursor is this black and white little life raft looking thing, and it's currently in the center of the world. If it was like off here, let's say, we could scale and it would scale relative to that, but to get it back, we're just going to hit Shift S and then say cursor to center, and now it's back at the right place. So anyway, now we're going to scale Z 1.59, and then we're going to take this, we got to figure out how wide it is. So I'm going to open the jaws of my micrometers and then bring it back down, and it looks like it's 37.95, and I bet you it's square too, so let's actually see. So it's actually not square, it's actually slightly slightly wider than it is high. 37 point. tall was this? So 37.95. So we're going to scale in the Y, which is actually the front. So it's going to be like we're looking from this sort of perspective, I suppose. Well, actually, since we're looking from 0, it's going to be more like that, but to you guys it's like that. So we're going to scale this by 37.95 and hit enter. And then we're going to scale X 38.1 and hit enter. And now we can sort of see that this piece of printed circuit board is sort of coming to be exactly how we want it. And so we're just going to keep on following through and measuring each one of these, each one of the components that have actually been soldered onto this PCB. So the next one I think is I'm going to actually take this lens housing and I'm going to measure that guy. So that's going to be 20.20 tall. And we can actually hit Tab, Shift A, add a new cube, Tab, scale by 0.5, grab Y 0.5, grab X 0.5, grab Z 0.5. So the grab and scale are G and S respectively. So that was 20.20 in the Y direction. Well, you know what? I'm actually going in the from the top left, so I'm actually not going from this text direction right here. I'm actually, this is my center. So we're going to scale Y by 20.2, and then we're going to scale X. I'm actually going to take the width dimension right here, and that's going to be 20.2 as well. And now we need to find the thickness, so I'm actually going to use the opposite end of the micrometers to find that. I'm just going to take that. I'm trying to get as accurate as possible, but there's going to be some human error involved. Looks to be about 3.5, or 3.05 actually. So I'm going to scale Z 3.05. Grab Z 1.59. And then what I want to do is I want to actually find the distance this way. So from the edge of the PCB to the edge of the lens housing. So I'm actually just going to go like that. You can see that. And then I'm going to read. It's going to be basically 9.34. So grab on the Y 9.34. And then I'm going to find this distance, which is probably very similar. that ends up being 8.66. Grab x, 8.66. And now we have the beginnings of the actual camera housing. So we can see that. So what I'm actually going to do now is something that I think everybody enjoys, and that's actually coloring it. So I'm going to go over into the materials property. I'm going to change this material name to PCB material. Change the diffuse to be blue. Specular, I don't know, to be sort of yellowy orange like the copper that's underneath the PCB. This is going to be the lens housing material. It's going to be an all black with 0 specular. And so that's sort of coming together, maybe a little bit. And now I want to actually figure out these two little details right here. They're actually screws that get screwed into the back, which are these screws. So there's two little screws that are actually screwing on that lens housing into the CMOS sensor. I assume it's CMOS, but anyhow, I actually just want to get the size of those so that I can put in little cylinders there. So that's going to be 4.45 for each of those in diameter. So I'm actually just going to hit Shift A to create a new mesh. It's going to be a cylinder. I'm going to hit Tab, scale by 0.5, grab Z 0.5, GX 0.5, GY 0.5, and then I'm going to scale the Y by 4.45 and scale the X by 4.45. And then scale Z by, and I can't quite remember the distance for this camera housing of how high it was. I think it was 3.05. Grab Z 1.59 to get that up on top of the PCB. And then I actually just want to measure what the actual distance is between the center of this cylinder and that datum face that we've been measuring from, and that's going to be about 18 millimeters. So grab Y 18 millimeters, and that's actually going to be the same distance as when we originally measured this, when we were going out from the face to the face of the lens housing. That's going to be 9.13. So grab X 9.13. Oh. Oh. Yeah, that's actually going to be a little bit less than that because of the thickness of the cylinder, so it's going to be 5.74. So now we have that right there. You can actually remove that material, the lens housing material, and then we can actually press Shift and D, and then hit Tab right away to bring us back into edit mode. Grab X, and then we can go the distance of the width of this lens housing in order to arrive on the other side. It's going to be 20.13. And something doesn't really seem quite right. So we're going to have to grab this.